Hello again. Welcome back. It's been a while, but let's get to business. Let's do Newton's second law of motion. So we have a question. A 2 kg wooden block is on a metal surface that is at angle 30 degrees to the horizontal. The wooden block is connected by a frictionless pulley to a 5 kg mass piece, which is hanging vertically. So as you can see, this is 5 kg hanging, then we have 2 kg on that inclined surface. So they're saying the system is free to move. So before we can start answering the questions, they're saying the system is free to move. They didn't mention which direction is the system moving. They just said it's free to move. So before you start answering the question, you must check which direction is the system moving to. So let's check. We have 2 kg here on the incline. We have 5 kg this side. So by looking or by the sense, let's check. 5 kg is bigger than the 2 kg block. So it's obvious that this one, it has the bigger weight than this one. So that means now 5 kg block will move down. That means the 2 kg block will move up the incline because this is bigger than this one. So 5 kg will move down, and then, or they will move vertically downwards, and then in the 2 kg block it will move up the incline. So now, since we know that the system now is moving to which direction, let's continue. The coefficient of kinetic friction between the wooden block and the metal plane is 0.3. So we're given 0.3 as the coefficient of kinetic friction. The kinetic, it means that the object is moving. So remember, the static means stationary, and then kinetic, it means moving. So 3.1, they are saying define the term kinetic friction. So kinetic friction, this is the frictional force that opposes the motion of a moving object. So we can say 3.1 kinetic, let me say kinetic friction is a force that opposes the motion of a moving object. Yes. So kinetic friction, this is the force that opposes the motion of a moving object. Now let's move to 3.2. 3.2 says draw a labeled free body diagram showing all the forces acting on the 2 kg block or the 2 kg wooden block. So before you draw the free body diagram, first you check the mark allocation. So the mark allocation, it represents the number of forces that are acting on that object. So check, we have 4 marks. That means we must show 4 forces acting on that 2 kg block. So let's check. A 2 kg block is on an incline. So let's say this is the 2 kg block. So since it's inclined like this, normal force is always perpendicular to the surface. So we must make sure that normal force is not going straight up, it's perpendicular to the surface, it's following the surface. So another thing, we have weight. Weight is always downwards. Then we have the tension. This tension is the force that is applying on the string or on the rope. So it's going up the incline. So this is the tension going up the incline. And then since the block is moving, it means that there is a force that is opposing the motion of this object, which is the frictional force opposing the motion. So now let's transfer this free body diagram. This is 3.2. So this is our free body diagram. Then we said we have the normal force perpendicular to the surface. Make sure it's not going straight up. And then we have weight going downwards, as always. Then there's a tension up the incline. This is the tension. And then the frictional force opposing the motion. So this one's going down the incline. This is the free body diagram that you're supposed to draw. So this is 4 marks. It means that the mark allocation will be like this. You have 1, 2, 3, 4. So this is your 4 marks. Or you can draw like this. Sometimes we accept. It's either you draw this one or you show the components of this weight, because the object is not on a horizontal surface. That means you can show it like this, the free body diagram. Normal force perpendicular to the surface, normal force. This is the normal force. And then this tension going up the incline, tension. And then the frictional force. This is the frictional force opposing. And then this weight, it has components. That means it has the perpendicular weight. This one is always moving straight with the normal force. So we call it a weight perpendicular. And then there is a weight parallel. This one is always moving parallel to the surface. So this is the weight parallel. That means if you draw this one, it's also accepted. You're going to have your mark here, your mark here, your mark, and then here you're going to have another mark. So weight perpendicular and the weight parallel, that is one force, which is weight. So we accepted that one. So let's move to the next question now. 3.3, calculate the kinetic friction experienced by the 2 kg block. So it's inclined now. So let's check it before we start calculating. They want to know the frictional force. So 3.3, this is the formula. First you write down the formula. Fk is equals to the coefficient of kinetic friction multiplied by normal force. So you take this formula straight from the formula sheet. So now let's check normal force. What is normal force? Normal force, now you check this free body diagram. Check normal force. Normal force is equals to weight perpendicular. They're moving straight. So this one, it moves straight with normal force. So these two forces, they are equal. But now what is weight perpendicular? Weight perpendicular is mg cos of theta. That is mg. So that means now normal force is equals to, in this situation, normal force is mg cos of theta. So you come back to the formula now. You substitute your normal force, the coefficient of kinetic friction. Now your normal force is mg cos of theta. So now what is the coefficient of kinetic friction? The coefficient of kinetic friction is given as 0.3. So you just write 0.3. And then m, this is the mass of an object, which is the 2 kg, times g, this is the acceleration due to gravity, which is 9.8. Then cos of what? Cos of the given angle, which is 30. That is the given angle. So that is the cos of 30 degrees. Then punch the calculator. That gives us 5,09 Newton. So this is the frictional force experienced by the 2 kg block when it moves up the incline. Now let's check the next question. The next question says state Newton's second law in weights. So Newton's second law in weights, they were specific, they said in weights. So this is 3.4. Newton's second law states that when a net force or a resultant force act on an object, the object will accelerate in the direction of the force. So you take this one from the exam guideline. So it will, when a net force acts on an object, the object will accelerate in the direction of the force, and the acceleration is directly proportional to the force and inversely proportional to the mass of an object. So you state Newton's second law like this: when a net force acts on an object, the object will accelerate in the direction of the force, and acceleration is directly proportional to the force and inversely proportional to the mass of an object. That means when you increase the net force or when you increase the force, that means acceleration also increases. But when you increase the mass of an object, it means that you are decreasing the acceleration. That's what Newton's second law means. So now let's move to 3.6. 3.3, they said, 3.5, calculate the acceleration of the system. So when you check, since they are connected, that means they are moving with one acceleration. That means if 5 kg block is moving with 10 meters per second squared down, it means that a 2 kg block is also moving with 10 meters per second squared, but up the incline. So that means we need both objects to find the acceleration. So let's open a new page. So, but before we calculate, that means we need to see the free body diagram of this object. So let's say already we have the free body diagram for the 2 kg block. Let's redraw it. The normal force acting on an object perpendicular to the surface, and then the tension up the incline, then the friction opposing the motion, and then the weight parallel, then the weight perpendicular. So on this one, to find the acceleration, that means we need the parallel forces, or the forces that act parallel to the surface. So this is the 2 kg block. Now let's check the 5 kg block first. This is the 5 kg block. Let's check the 5 kg block. 5 kg block is just hanging, but it's moving down the incline. It's moving down, vertically downwards. So this is 5 kg block. So we see tension. This is the tension. This is the tension. And then there's weight on this one going down. This is the weight of an object. That means on a 5 kg block, there are only two forces acting on that object. So now that means this is our net force according to the free body diagram. Now let's move. This one is 3.5. So 3.5. We apply Newton's second law in both objects. So we start from, let's say we start from the 5 kg block. We start from the 5 kg block. We apply Newton's second law, which is F net is equals to ma. Now let's check our F net. Since the block is moving down, that means the force that is going down, it takes the positive sign. So we have weight, which is going down. That means it takes the positive sign. Then tension is opposing the motion. That means it's going up. So we have plus minus tension. Since it's opposing, take the negative sign. Then it's equals to ma. Now weight, which is mg, minus the tension is equals to ma. Then what is m? M is the mass of an object, which is 5 times 9.8 acceleration due to gravity, minus tension is equals to m, mass of the object, which is 5, acceleration a, because we're calculating for the acceleration, we don't know the acceleration. So 5 times 9.8, that is 49, minus t is equals to 5a. So we take tension to the other side, it becomes t is equals to 49. We take 5a to the other side, it becomes minus 5a. So let's say we call this one equation 1. Now we move to 2 kg block. This is 2 kg block. We apply the same thing. F net is equals to ma. Now let's check. These are the forces acting parallel to the surface. Since 2 kg block is moving up the incline, it means that the tension, it takes the positive side. So we have T plus, then the rest of the forces that are opposing, that means they take negative sign. So we have negative friction plus negative weight parallel is equals to ma. So now tension, we don't know the tension, minus frictional force. Already we did calculate the frictional force. So on the frictional force we found 5,09, that is the frictional force. So we have 5,09 minus weight parallel. Weight parallel is the same as mg sine of theta. So m, which is 2, since we are talking about the 2 kg block, times 9.8 sine given angle, which is 30 degrees. So we just take it straight here. That is 2 times 9.8 sine 30 degrees. Then it's equals to m, which is 2. The focus is 2 kg. Then a. So when we punch the calculator here, t minus negative plus negative, that give us negative. So it will give us minus 14,89. That means this one is 1 over 2. So 1 over 2 times 2 is 1. 1 times 9.8 is 9.8. So 9.8 plus 5, that gives us negative 14,89. Then it's equals to 2a. So let's make t the subject of the formula on this side. So 2a, this one change the sign, become positive 14,89. So let's call this one equation 2. Now, before we move, this is simultaneous. Let's check this side. Equation 1 is equal to t. T is equals to, this equation is equals to t. This equation is equal to t. This one, it means that the equation 1 is equals to equation 2. So now, what is equation 1? Equation 1 is 49 minus 5a is equals to equation 2, 2a plus 14,89. Now, let's group the like terms. Let's take this one, 2a, to the other side. We're going to have negative 5a minus 2a is equals to, we take 49 to the other side, it becomes negative 49 plus 14,89. So this one is give us negative 7a is equals to, this one is going to give us negative 34,11. And then we divide by negative 7, then acceleration is equals to 4,87 meters per second squared. Then the question said calculate the acceleration. So that means we must also include the direction. So it's 4.87 meters per second squared way up the incline. So this is the acceleration of the system. So now let's check the last question. The last question says we must calculate the tension. On the string between the two blocks. So to calculate the tension, it's easy now. You just choose one of the equations. So let's say this one is 3.6. You can take equation 1, t is equals to 49 minus 5a, and then 49 minus 5. What is a? A is the acceleration, which is 4,87. So this is 4,87. Then what is 49 minus 5? 5 times 4,87. That gives us 24,65 Newton. So this is the tension acting on the string between the blocks. So that is the end of our questions. So thank you for watching, and please don't forget to subscribe. Thank you.